So in this video, we're going to look at dividing radicals. Now, in a previous video, I've looked at multiplying radicals, adding, subtracting radicals, simplifying radicals. So I would go back and check those out. As always, if you like this video, if it helps you, you can comment, subscribe, whatever you need to do. So let's look at dividing radicals, and we're going to look at a few quick examples. All right, so dividing radicals is very similar to multiplying radicals. So like, let's say we have the square root of 6 divided by the square root of 2. If we divide radicals, now of course it's already split up for us here, but let's say it were written like this, the square root of 6 over 2. Either way, it would look like this first example, where you essentially square root the top, keep the fraction, and then square root the bottom. So it's really just square rooting the numerator over square rooting the denominator. All right. Now I'm going to start with it just set up like this, just because it makes it easier to understand. So when we do this, we can actually divide what we have under our square roots, and we can say 6 divided by 2 is just 3. But since we're dealing with square roots, we're going to leave that 3 underneath a radical, and this would actually be our answer. So let's look at another example, and you can probably start to do these on your own. Let's say we had the square root of 12 divided by the square root of 3. All right, so once again, we're just going to divide what's underneath our square root, so 12 divided by 3, which gives us 4, and then we're going to keep that under a square root. Now, we can actually go further with this because the square root of 4 we know is 2, so there's our answer. Let's do one more simple one, and then we'll jump into some complex problems. So let's say we have, I don't know, let's do the square root of 25 divided by, well actually let's not do that. Let's do the square root of 20 divided by the square root of 4. All right, so now once again, we have two square roots. We can divide what's under our square root. 20 divided by 4 is 5, and then we can keep that under a square root. All right, it's that simple. Now, let's say we were to change this a little bit and we had coefficients. Like let's say there were a, I don't know, a 10 out here and a 2 out here. All right, now we do this the exact same way we did multiplying, where we just divide the coefficients just like we normally would. So we would say 10 divided by 2 is 5, and that stays outside of a radical because it's already outside of a radical. Then we can continue and do what we've already done, which is 20 divided by 4, which is 5, but keep that under a square root. All right, so like once again, another quick example, let's say 6 square root, let's just say square root 10 divided by 2 square root 5. All right, let's just keep it simple. So once again, if we have this issue, we can divide our coefficients. 6 divided by 2 is 3. Keep that outside of our radical. Then we can divide what's underneath our square roots and leave it under our square root. 10 divided by 5 is 2, so there's our answer. All right, so now let's jump into some complex problems. And for these, we're actually going to end up coming across some variable problems, but that'll be okay. So let's look at one without a variable. Let's say we have 12, and then we have the square root of 160 divided by 2 square root 5. All right, so now let's pause this video, see if you can do this on your own, which most of you probably can. So give it a shot. All right, so once again, we're going to divide our coefficients. 12 divided by 2, and that's going to give us 6, and we're going to keep that outside of a square root. Now what goes in the square root is 160 divided by 5. And that's going to give us 32. Now, here's what makes this problem more complex, because you might be thinking, that's the exact same thing we did for the other problems. Now, 6 square root 32 can actually be broken down further. This square root of 32 could be simplified. So if we have to, well, let me rephrase it. If we have the opportunity to simplify, we're supposed to simplify. It's kind of like fractions. All right, so we're going to take this 6 square root 32, and we're going to break it down further. So we're going to take 6, and then we're going to take the square root of 32 and see if we can break it down into 2 separate radicals. And we want to break our numbers up by dividing 32 by the biggest perfect square that divides 32. And let's see if you could figure that out, which you probably can. it would be 16. So we would use 16 and 2. Once again, in a separate video, I've gone over simplifying square roots or radicals, so go back and check that out if you need some extra practice. So now, we can break down or bring down 6. We can do the square root of 16, which is 4. And then we can keep our square root 2 because 2 can't be broken down any further. So then our final answer is going to actually be, let's see, 24 square root 2. And that would be our answer. All right, so now let's make this a little bit more complicated. And let's look at an example with variables. All right, so let's say we have the square root of x to the third, y to the ninth, all over the square root of x to the second, y to the fifth. All right, now this may look complicated, but let's just see if you can give this a shot. All right, so now when we're dividing what's underneath our square root, you'll notice that we have variables. If you remember, when we divide and we have variables, we actually subtract these exponents. All right, so we're going to keep everything under a square root, but we're going to do x to the third divided by x squared, which once again means we're essentially doing this, x to the 3 minus 2. All right, so we subtract our exponents when we divide. So that's going to leave us with, let's see, x. So it'd be x to the first power. All right, so now let's do the same thing with y to the ninth divided by y to the fifth. That's going to give us y to the fourth, but that's going to stay underneath our radical. So now, this is where a lot of people would say, okay, there's the answer. However, we need to break this down further. And once again, I've actually done a video over simplifying radicals with variables, so go check that out if you need extra practice. So the first thing I would do is break up x and y. So the square root of x, and then we've got the square root of y to the fourth. All right, now, the square root of x, there's no way to rewrite x so that it has a power or an exponent that's divisible by 2. Because if we go from 1 to 0 to -1, it's just going to make things more complicated. So this square root x is actually just going to be the square root of x. That's going to be in our answer. So it can't be broken down any further. So we're done with that part. Now, let's see if you remember, what am I supposed to look for here when I'm doing the square root of y to the fourth? So what you're looking for is the index, which is 2. Because that 2 tells you what you're going to divide this exponent 4 by. So if you want to do the square root of y to the fourth, you just divide this 4 by 2, and that gives you your answer. So the square root of y to the fourth is y to the second, but it's no longer under a square root because it came out evenly. So this would actually be our answer. All right, let's look at, let's see, let me look. I think actually this may be where we leave off. Let's look at one more just to give us an idea. So let's look at one last one. Let's say I had the square root of 48 over 16. All right, so now once again, when we do this, we could rewrite this several ways, but essentially if everything's under the square root already, you can just divide this and keep it under a square root. So this is actually just 48 divided by 16, which is 3, but we keep that under a square root, and that can't be broken down any further. All right, so remember, when you are dividing with radicals, you divide like normal, you just keep your answer underneath a radical.